SpaceX is ready with its latest updates from their Starbase facility. As at the orbital launch mount, progress unfolds with coordination by workers. The installation of the Deluge piping and water-cooled steel plates is well underway, bringing us one step closer to the final test. Meanwhile, there are also new developments at the Sanchez site and Massey test site. But that's not all. NASA achieves a monumental water recovery milestone on the International Space Station, unlocking new possibilities for sustained life beyond Earth. And Europe hands over the Artemis II moonship service module to NASA, making the way for lunar exploration. How close are we to the next test? Dive in this video to find out. At SpaceX's Massey test site, significant developments have unfolded. The NC-31 test nose cone, previously placed on the structural test stand, has now been removed and set aside. Unfortunately, due to the damage it sustained during testing, it is likely to be scrapped. However, considering SpaceX's fondness for surprises, there may still be unforeseen plans in store for this nose cone. Simultaneously, the teams at the Massey site have been hard at work constructing the new booster test stand. This stand will play a crucial role in booster-proof testing, and is expected to see its inaugural use with Booster 10, currently stationed at the Rocket Garden. The construction progress of this test stand indicates Space's commitment to continually enhancing their testing capabilities. Moving on to Starbase proper, the production site, known as the Sanchez site, has been a hotspot of activity. Notably, preparations are underway for a new foundation, which appears to be of similar size to the ground fabrication building currently being dismantled at the production site. Speculations arise that SpaceX may be relocating the ground fabrication building from the production site to the Sanchez site. The Sanchez site holds significant components, including the water-cooled steel plates utilized for the orbital launch mount and prefabricated mega bays. Observing the construction progress, we can witness the impressive advancement with nearly 2 fully built mega bay sections, a third one nearing completion, and preparations for the commencement of construction on the 4th section. In terms of the water-cooled plates, 2 of them appear to be close to deployment, with the removal of most equipment and scaffolding. The 3rd plate still requires further work, as indicated by the remaining equipment and scaffolding surrounding it. As we shift our focus to the Rocket Garden, a new foundation is being constructed next to Booster 10. While this location is typically used for display or storage purposes, the foundation's specifications do not align with expectations. This raises questions about its purpose. One possibility is that it may serve as another engine installation stand, similar to the one currently supporting Ship 26. Alternatively, it may have an entirely different function. Continued monitoring will shed light on the developments in the coming weeks. Regarding Ship 26, there have been fewer recent activities associated with it. However, in close proximity, discarded nose cone parts have been observed, likely remnants from the nose cones seen departing from 10-3 last week. The presence of these parts indicates ongoing modifications and improvements to SpaceX's nose cone designs. Transitioning to the production site's 3 bays, intriguing developments have taken place. Notably, Ship 28's payload bay door has been removed. That is an unusual move that sets it apart from the process observed with Ships 24 and 25, where their doors were sealed over. The reasons behind this decision remain unknown. It remains to be seen whether a new door will be installed later, or if SpaceX intends to modify the existing one. Close monitoring of the situation will provide further insights. Meanwhile, Ship 29 remains stationed at the high bay after being fully stacked last week. While limited external details are visible, it is reasonable to assume that extensive work is being carried out to outfit and prepare the ship for testing. This process likely involves the installation of new upgrades and fine-tuning its systems. Starting with Ship 26, recent observations indicate limited activity associated with the ship. However, discarded nose cone parts have been spotted, suggesting ongoing preparations. One intriguing sight is the removal of Ship 28's payload bay door, raising questions about its purpose. Meanwhile, Ship 29 is being outfitted and prepared for testing, hinting at its imminent role in upcoming missions. Moving to the Mega Bay, we witness the stacking progress of Booster 12's liquid oxygen tank, which has been completed except for the engine section. Aerial views show the teams geared up to lift Booster 12's forward dome section. Additionally, the next section of the methane tank has already been staged outside the Mega Bay, ready for stacking. A crucial component, the methane transfer tube, has also been positioned for installation. These visual cues indicate the steady advancement of SpaceX's construction efforts in the Mega Bay. In Nick's recent flight over Starbase, significant progress on the new Mega Bay was captured. Aerial shots reveal that 2 corners of the first level have been erected, while 2 more corners have been staged nearby. Notably, one of the staged corners has already been installed, as observed in Nick's ground videos. As of now, the 4th corner has also been successfully put in place. With 4 sections well underway in their construction at the Sanchez site and the installation of these 4 corners, it appears that more than half of the new megabay may be completed before the end of the month. This impressive progress showcases SpaceX's efficient time management and dedication to expanding their facilities. Now let's explore the position of the nose cones that were previously relocated. At least 2 of them have been accounted for. Ship 30's nose cone was moved to the ring yard, where barrel sections and rings are staged before being stacked at the base. Considering that Ship 28 and Ship 29 are expected to be stacked next, the relocation of Ship 30's nose cone to the ring yard aligns with the anticipated sequence. What catches the eye are the intriguing marks on the nose cone. Upon close examination, a circular black structure can be noticed on the leeward side's center-right section. The purpose of this structure raises questions. Is it for a thruster? Will a similar cutout be observed on the other side of the nose cone when Ship 30 is stacked? As more information emerges, we eagerly await answers to these intriguing inquiries. Regarding the other nose cones, some have been scrapped, as witnessed earlier at the Sanchez site. Meanwhile, others have returned to Tent 3. But this time from the ring yard side instead of the windbreak side. Notably, one particular nose cone, which we speculate could be for Ship 34, remains outside. The fate and purpose of this nose cone continue to pique our curiosity. Shifting our focus to the Star Factory expansion, significant progress can be observed. The installation of beams and columns for the new part of the building has started, marking the initial stages of this ambitious project. Aerial shots provide a glimpse of the massive outline of the future Star Factory expansion, hinting at the scale and capacity it will offer once completed. It is exciting to envision the increased vehicle production potential that SpaceX will achieve in this expanded facility. At the Starbase launch site, significant developments have taken place this week, with a particular focus on Ship 25's aborted spin prime test and the ongoing work on the orbital launch mount to install Deluge piping and prepare for the installation of water-cooled steel plates. Ship 25's spin prime test was eagerly anticipated, as teams had been preparing for it by extending the flaps of the ship and conducting preliminary testing. The startup of the methane recondenser indicated that methane loading was about to occur, hinting at engine testing. Propellants were loaded onto Ship 25, and engine chill had commenced. However, much to the disappointment of observers, the test was abruptly aborted. SpaceX may repeat the testing this week, this time aiming for a successful test rather than an abort. The excitement continues as we eagerly await the next round of testing. Turning our attention to the orbital launch mount, progress has been made in recent weeks. Aerial shots reveal the installation of large curved pipes located next to the new water tanks. These pipes curve upwards and then downwards to connect underground pipes that will ultimately lead to the orbital launch mount. This design allows water to fill the pipes up to this point without flowing down to the mount, similar to the function of flush pipes in a toilet. The water will only reach the orbital launch mount when pressure is applied from the pressure tanks situated behind the water tanks. Additionally, one of the manifolds required for the orbital launch mount plates can be seen staged near the pressure tanks. In the near future, we can expect the installation and integration of these components, bringing the system closer to completion. However, before any further progress can be made, all the foundations for the new steel plates need to be finalized. The construction process at the orbital launch mount has seen an abundance of rebar installation. Sheet metal was previously placed around the mount's perimeter to protect the ground from collapsing, enabling workers to install a significant amount of rebar since then. This rebar will soon be covered in concrete, creating a solid and stable foundation for anchoring the steel plates. While some rebar remains to be installed near the orbital tank farm berm, it is expected to be completed in the near future. Excitement mounts as a long convoy of concrete trucks is anticipated to arrive at the launch site, marking a major milestone in the progress of the orbital launch pad. In just 2 months since Starship's integrated flight test, the site has transformed from a smoking crater to a nearly completed foundation for the steel plates. The continuous progress raises hopes for an imminent launch and an impressive launch cadence thereafter. Looking beyond the launch site, the advancements at the production site indicate that SpaceX is gearing up for a rapid succession of launches. With the pace of progress, the possibility of human landing system tests being conducted in the not-too-distant future becomes increasingly feasible. Such tests are crucial for achieving the ambitious goal of returning humans to the moon before the decade's end. However, it is important to note that Starship won't be the only vehicle responsible for this lunar endeavor. The developments at the Starbase launch site, including the aborted Spin Prime test and progress on the orbital launch mount, highlight the ongoing efforts to advance SpaceX's ambitious space exploration plans. As the groundwork continues to take shape, anticipation grows for the next launch and the potential for human space exploration milestones. Up next, NASA achieves water recovery milestone on International Space Station. NASA has reached a significant milestone in its quest to develop life support systems for space missions. The agency's latest achievement involves the successful recovery of water on the International Space Station using the Environmental Control and Life Support System. This groundbreaking accomplishment brings NASA one step closer to its goal of regenerating or recycling consumables, like food, air, and water during long-duration space journeys. In order to sustain crew members on missions beyond low Earth orbit, it is crucial to recover as much water as possible. The ECLSS, a combination of hardware on the space station, includes a remarkable water recovery system. This system is responsible for collecting wastewater generated on the ISS and directing it to the water processor assembly, which works its magic to produce drinkable water. One of the specialized components of the water recovery system utilizes advanced dehumidifiers to capture moisture released into the cabin air from crew breath and sweat. This moisture, along with other sources of wastewater, is carefully treated and processed by the WPA to ensure its cleanliness and safety for consumption. The technology behind this system has undergone extensive testing and improvements to ensure its effectiveness in the challenging environment of space. The recovery of water from urine is another crucial aspect of NASA's life support systems. The urine processor assembly plays a vital role in this process by employing vacuum distillation to extract water from urine. Previous technology demonstrations on the ISS have allowed for enhancements to the UPA's distillation assembly, which has led to significant improvements in water recovery. However, the journey to achieving the 98% water recovery goal was not without its challenges. NASA introduced the brine processor assembly as a solution to extract the remaining wastewater from the urine brine. The BPA utilizes a special membrane technology and warm, dry air to evaporate the water content, leaving behind only the brine. The humid air generated during this process is collected by the station's water collection systems, along with moisture from crew breath and perspiration, completing the water recovery cycle. The success of the BPA has been instrumental in helping the ECLSS achieve the remarkable milestone of 98% water recovery. This accomplishment not only demonstrates the advancement of life support systems, but also ensures a more sustainable and self-sufficient approach to space exploration. The ability to recycle and regenerate water on board eliminates the need for excessive water resupply missions and allows for greater focus on scientific endeavors during space missions. NASA's team of experts at the Johnson Space Center and beyond are thrilled with this achievement, recognizing its significance in the evolution of life support systems. Christopher Brown, a member of the team, expressed his admiration for the continuous circulation and reuse of water on space missions. He explains, "Keeping that running is a pretty awesome achievement." In addressing potential concerns about drinking recycled urine, Jill Williamson, the ECLSS Water Subsystems Manager, emphasizes that the reclaimed water is cleaner and purer than what is commonly consumed on Earth. Rigorous processes, similar to those employed in terrestrial water distribution systems, ensure the water's quality and safety. The team's extensive ground testing provides utmost confidence in the production of potable water for the crew's consumption, food preparation, and hygiene needs. As NASA looks ahead to more ambitious missions beyond low Earth orbit, the significance of regenerative ECLSS systems becomes increasingly evident. The inability to rely on resupply missions during exploratory ventures highlights the importance of reclaiming and utilizing all available resources on board. By reducing the need to transport large quantities of water and oxygen, these advanced life support systems enable more scientific experiments and equipment to be included in space missions. Furthermore, the reliability and robustness of these regenerative systems alleviate concerns for the crew, allowing them to focus wholeheartedly on the true purpose of their mission. The successful water recovery milestone achieved by NASA's ECLSS systems is a testimony to the agency's dedication to innovation and sustainability in space exploration. Up next, SpaceX launched 47 Starlink satellites early Thursday. In another major milestone for SpaceX, the company is set to launch a substantial batch of its Starlink internet satellites in the early hours of Thursday morning. The Falcon 9 rocket will carry a payload of 47 Starlink spacecraft, aiming to further expand the broadband mega-constellation. The launch is scheduled to take place at 3:19 a.m. from California's Vandenberg Space Force Base. If all goes according to plan, the Falcon 9's first stage will separate and return to Earth approximately 8 minutes and 45 seconds after launch. The precision landing is expected to take place on the SpaceX drone ship, Of Course, I Still Love You, stationed in the Pacific Ocean. This particular booster has an impressive record, as it will mark its third launch and landing, showcasing the reusable capabilities of SpaceX's technology. Following the successful return of the first stage, the Falcon 9's upper stage will continue its ascent, carrying the 47 Starlink satellites towards their destination. Roughly 19 minutes after liftoff, the satellites will be deployed into low Earth orbit, where they will join the existing constellation. SpaceX has been steadily deploying Starlink satellites, with nearly 4,600 launched to date. Out of these, more than 4,200 are currently operational, according to astrophysicist and satellite tracker Jonathan McDowell. The company's ambitious plans for the future include permission to deploy a total of 12,000 Starlink satellites. Additionally, SpaceX has applied for approval to launch an additional 30,000 spacecraft, aiming to enhance global broadband coverage and improve internet connectivity worldwide. Thursday's Starlink mission is part of an early morning spaceflight doubleheader. As a United Launch Alliance, ULA, Delta Navor, Heavy Rocket is also scheduled to launch a classified satellite for the U.S. National Reconnaissance Office from Florida's Cape Canaveral Space Force Station just minutes later at 3:25 a.m. The back-to-back launches demonstrate the increasing frequency of space missions and the advancement of commercial space capabilities. SpaceX's dedication to reusability and efficiency has enabled them to conduct such frequent launches, paving the way for a new era of space exploration and satellite deployment. Up next, Europe hands Artemis II Moonship service module over to NASA. The next mission to carry humans to the Moon, known as Artemis II, is one step closer to becoming a reality, as NASA takes possession of the vital hardware that will support the astronauts on their journey. This hardware, called the European Service Module 2, arrived at NASA's Kennedy Space Center, KSC, in Florida back in October 2021. Since then, rigorous tests have been conducted to ensure its reliability and safety for the crew on board. In a recent milestone, the documents finalizing the transfer of the ESM-2 from the European Space Agency to NASA have been signed. A small ceremony held at KSC on June 14th marked this important occasion. Artemis II astronaut Victor Glover, accompanied by Howard Hu, NASA's Orion program manager, visited the facility that day and participated in the signing of the agreement. Anthony Thurkettle, the ESM production manager from ESA, also added his signature to the documents. While the handover may be considered a formality, it signifies a significant achievement for the Artemis program. Anthony Thurkettle acknowledged the collaborative effort involved, stating, "It could not have been achieved without the tremendous effort of all the teams involved." He further emphasized ESA's commitment to continue working closely with NASA and industry colleagues in preparing the Orion spacecraft for launch and throughout the Artemis II mission. Under NASA's Artemis program, human exploration is being reintroduced to the Moon with the goal of establishing a sustainable presence on its surface. Artemis I, the uncrewed precursor mission, successfully launched in November 2022, sending an Orion capsule into lunar orbit. Now, Artemis II, the first crewed mission of the program, is scheduled to take place. This historic mission will carry NASA astronauts Victor Glover, Reed Wiseman, and Christina Koch, along with Canadian Space Agency astronaut Jeremy Hansen, on a 10-day journey around the Moon and back. During the Artemis II mission, the Orion capsule will heavily rely on its service module for essential resources and propulsion. The ESM serves as the storage and supply unit for critical resources such as air, water, and electricity. Additionally, it houses the fuel tanks and rocket engine, which serve as the primary propulsion system for the Orion spacecraft. The ESA highlights that the service module comprises 33 thrusters, 6 fuel and storage tanks, and approximately 7 miles of wiring throughout its systems. To provide a relatable analogy, envision the Orion spacecraft as a car, and the service module as both the engine under the hood and the wheels. With the acquisition of both components, NASA is now on the verge of assembling the Artemis spaceship. Before integration, the ESM-2 will undergo a series of tests to ensure its proper functionality and compatibility with the Orion capsule. NASA has recently shared a photo of the service module being transferred to its final assembly and system testing cell, where it will undergo testing and integration procedures. Assuming everything proceeds as planned, the ESM-2 will be joined with the Orion capsule later this year. Once integrated, the combined spacecraft will be stacked together with the Artemis II Space Launch System rocket inside the colossal vehicle assembly building at Kennedy Space Center. The target launch date for this momentous mission is set for November 2024, as NASA continues its dedicated efforts to return humans to the moon and push the boundaries of space exploration. With the integration of the Orion capsule and the ESM-2, the Artemis II mission will take a giant leap forward in its preparation. The combined spacecraft will undergo evaluations to ensure every component is functioning flawlessly and ready for the extraordinary journey to the moon and back. What do you think about the updates of the launch site? Share your views in the comment section below.